Welcome to my channel To Irrational. I'm Pranay Sharma and in this video we'll learn Trapezium Rule. Trapezium Rule is an approximate way of calculating numerical value of integrals. It is also known as Trapezoidal Rule, as trapezoid is another name for trapezium. This is one of the most common way of calculating numerical values of complicated integrals that we are not able to solve using traditional ways of solving integrals. Let's take an example where we are finding area under the curve of a function between 2 points A and B. In integration, we take a rectangle with a very small width at point X. The height of the rectangle will be fx and the area of the rectangle becomes the width into height, that is f of x into dx, assuming the height is same for the whole width. As integration is just addition of area of all such rectangles from A to B, we get this formula. Assuming dx is almost equal to 0, the approximation of the height becomes negligible. For trapezium rule, we use similar concept but take comparatively larger widths here. So let's divide our area into 6 equal widths. As we connect the tops with straight lines, we get 6 trapeziums with equal widths. Let's name them as D, and also the points of the parallel sides will name them as x1 to x7. The area of the trapezium is half of the width multiplied by the addition of heights of parallel sides. And if we add all of the trapeziums, we get an approximation of area under the curve. You can see where the approximation works. In some places we have missing areas and in some places we have taken extra area into account. But if we reduce the width of these trapeziums, of course the number of trapeziums will keep on increasing, then the approximation becomes smaller and smaller. Let's take an example. So we have find area under the curve y is equals to x square using trapezium rule between x is equals to 1 to 3 and 9 ordinate points. So we are assuming that we will be making 9 ordinate points, that means 8 divisions or 8 trapeziums in this curve. As we are making 8 divisions here, we will first figure out what will be the difference between each of those divisions, okay, or each of those points. So the simple formula would be b minus a by n minus 1. So here we have 3 minus 1 by 8, that gives me 0.25. Now our x values would be 1, 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.75 and 3. You can count, these are 9 values. Now using these values we'll figure out what are the possible values of y. So we just have to square them here. So we'll have 1.25 square will give me 1.5625. 1.5 square would be 2.25. 1.75 square will be 3.0625. 2 square 4. 2.25 square becomes 5.0625. 2.5 square would be 6.25. 2.75 square becomes 7.5625 and 3 square is 9. So according to the formula, you can write it in two ways. You can say it is half of d of, then first you can say y1 plus y last one, I will write it as yn right now, and then plus 2 times and all the between y's, so whatever y2 to yn minus 1. This is one way of writing. The other way you can say it is d into half of y1 plus yn last value plus all others only once, y2 plus yn minus 1. However you prefer, you can write this formula. That would be our area. So the approximate area that we will get would be first d would be 0.25 because that is the width that we have taken, multiplied by, I'll take half of first and the last value added together, so 10 by 2, and then add all other values, that would be from this point to this point. That gives us 29.75. So finally we will get 8.6875. If we were to calculate this integration, normally we would have said that integration of x square dx would give us x cubed by 3, and then we would substitute the values 1 to 3 and we'll get 27 minus 1 by 3, that is 8.667. So you can see nearly we got the same answer. So you might say it is approximately same. And if you increase the number of trapeziums, that means if you decrease the width of each of those trapeziums by increasing n, you will find that your answer becomes much and much closer to the actual value. Let's take another example. Y is equals to 2 by x for x being between 2 to 3, and we'll use this time only 5 ordinates. So first of all, width will be 3 minus 2 by 5 minus 1, that is 1 by 4, 0.25. So the possible values of x would be 2, 2.25, 2.5, 2.75 and 3. Accordingly, we'll calculate our values of y. So we'll have 1. I'll let these be fractions, so I will have something like 2 by 2.25, that gives me 8 by 9. Then 2 by 2.5, that is 4 by 5. 2 by 2.75 will give me 8 by 11 and 2 by 3. So the approximate area that we'll get will be 0.25 into half of 1 plus 2 by 3 and then addition of all these 3. That gives me approximate something like 2.41616. That is 0.25 into 3.24949, which gives us 0.81237. The actual integration here, 2 by x dx, would give me 2 log x, and the limits would be 2 to 3. So that would be 2 into log 3 minus log 2, that is 0.81093. So again, approximately we got very similar answer. If this was helpful, please let me know in the comments, and also write if any other concepts you would like me to tackle. Do like, share and subscribe, and I'll see you in the next one.